Hello everyone, welcome back to my channel. So we'll continue with the next lecture of the series from the chapter Basic Concepts in Chemistry. So far we have seen mole concept, masses and definitions and properties of matter. So continuing the mole concept part, we have seen only single relationship or formula. We can say number of moles is equals to the given mass of an atom or a molecule divided by its molar mass, to which we have written n is equals to m by m. Now we'll add two more relationships. The first one is for gases. So if we are given volume of a gas as V and the temperature is given to be 273 Kelvin and pressure is 1 atmosphere. So this condition is known to be STP, which is standard temperature and pressure. So at STP conditions, the volume of 1 mole of an ideal gas is always 22.4 liter. So irrespective of the gas, the volume occupied by 1 mole of any gas is 22.4 liter. For example, methane, if present as a 1 mole, will occupy a volume of 22.4 liter. Ethyne, another gas, having 1 mole as a quantity, will occupy volume of 22.4 liter. Oxygen, hydrogen. So irrespective of the gas being used, if the amount is 1 mole, the volume is 22.4 liter. This is what it means. So we can write that number of moles is equals to volume of the gas divided by molar volume. So molar volume is also, I am writing 22.4 liter. This is the condition has to be STP if we are using this constant. So this is the volume of the gas and this is the volume occupied by 1 mole of the gas. So this is N. So I am writing it here, V divided by 22.4 liter, and the condition is STP. This is important to have a STP condition. Now second relationship is with the number of molecules. Number of molecules represented as this. Since 1 mole has Avogadro number of molecules, so the given number of molecules, if divided by Avogadro constant, will give me the number of moles. So I can write it here, number of molecules divided by Na, and we know what is Na. It is 6.022 10 to power 23. So in general we can see and we can remember the formula. These three formulas can easily be remembered without any confusion by using its general form. What is the general form? N is equals to some known or some given amount. The amount can be a mass, could be a volume, could be number of molecules, divided by some known quantity or a constant, we can say. So known molar mass, as we know, for atoms such as hydrogen, it is 1 gram. It is always 1 gram. For oxygen we always take 16 grams. For nitrogen we take 14 grams, sulfur is 32 grams, and so on and so forth. So every element, every atom has a fixed molar mass, and that mass is, I have written, known. So number of moles is equals to mass over molar mass. So a known quantity or a fixed quantity which is a constant like Na and 22.4 liter. So this is the way we can convert given amount into its number of moles present. Next, which is very important part of mole concept, is balancing a chemical reaction. So whatever question you are going to attempt, anytime in terms of numericals you are going to do, you have to, the first thing you have to do is the balancing the reaction. Okay? So balanced chemical reaction basically has equal number of atoms. Each atom is equal in reactant side, which is the left side, and in the product side. For example, if I am doing a simple reaction of H2 and O2 to form water. So here you have to balance the atoms. Hydrogen is fine right now, oxygen 2, oxygen 1. So I will multiply with this 2 number. Now there are 2 oxygen atoms, which is balanced. But the number of hydrogens are not balanced. So 2 into 2, 4. Here it is 2. So I will multiply with 2, it will become 4. So now I have 4 hydrogens, 2 oxygens, 2 oxygens. Now this is called a balanced chemical reaction. The number I have added, or if there is no number, it means it is multiplied with 1. These numbers are called stoichiometric coefficients. So if I want to read this reaction in terms of, if I want to write in terms of words or in a sentence, I will write 2 mole of H2 combines with 1 mole of O2 to form 2 mole of H2O. So this is how we read a chemical reaction. So these constants are known to be stoichiometric coefficients or stoichiometry of the reaction. That this gives the ratio of reactants and the ratio of reactant to product. So this is how we read a chemical reaction. Now a chemical reaction involves combination, or it can be a decomposition of reactant to form product. So from there come certain laws which govern the chemical reaction from the quantitative aspects. So for that we have laws of chemical combination, how the molecules are combining. So in total there are 5 laws of chemical combination. The first one, which you have read before as well, is law of conservation of mass. Lavoisier, this is the name of the scientist, and according to this it says that the mass can neither be created nor be destroyed. It remains there in the form of reactants and products. So whatever is the total mass of the reactant present in a reaction, it completely converts into the products. So we can say the total mass of reactant is always equals to the total mass of product formed. For example, if I am taking a balanced chemical reaction like calcium carbonate thermal decomposition to form CaO and CO2 gas. So if 20 grams of this is decomposed to form 11.2 grams of calcium oxide, and you are supposed to calculate the amount of carbon dioxide formed. So here we know, because the completion of reaction, the amount of reactant and product has to be the same. So 20 gram will be equals to 11.2 gram plus X. So X comes out to be 20 minus 11.2 grams, which is 8.8 grams. So amount of carbon dioxide forms is 8.8 grams in the reaction. Here it is a complete decomposition of calcium carbonate. So even if there are more than one reactant, you can still apply this law. Only condition is the reaction goes to a completion. Everything which is present as a reactant has converted to a product. And total mass is same. And this law is also the basis of balancing a chemical reaction, where you balance the number of atoms and every atom has a mass. So you are basically balancing the mass on reactant and product side. The second law is law of definite means fixed proportion. Proportion means the ratios, or this you can also call it as a composition. This was given by Proust. According to this law, for a given molecule, the ratio of atoms which are combining to form a molecule, that remains fixed irrespective of the source they have been obtained from. For example, if you know that water is represented as H2O molecule, so you know whether it comes from rain, it's a rainwater, or it's a tap water, or it's a river water. All water will have H2O as the formula, where hydrogen is to oxygen ratio is always 2:1. So the ratio of the atoms, whether you consider in terms of mass or numbers, the ratio is fixed. So in one H2O molecule, we have 2 grams of hydrogen and 16 grams of oxygen. I am saying 18 grams of water. So the ratio is always fixed, or the number is always fixed. So let us see what kind of question you can get based on this law. So I have a question which says, in an experiment, coke, which is carbon, when burnt in oxygen, it forms carbon dioxide gas. All are gases. This is solid. So 12 grams of coke burned to form 44 grams of carbon dioxide in experiment 1. In another experiment, I am taking carbon source as a charcoal. So that is also carbon. So there I am using 36 grams. It is combining with oxygen to form CO2 gas. And now it is forming 132 grams. So what we have to do in experiment 1 and 2? We have to determine the ratio of carbon is to oxygen in the product. Okay, so we have reactant carbon, oxygen and product CO2. Initially we are using 12 gram to get 44 gram. And using the first law, we can determine the mass, which is 44 minus 12, which is coming out to be 32 grams. Similarly, here we have 36 grams, which is forming 132 grams of CO2. So if we subtract the two, we will get this mass to be 96 grams. So in CO2, which is 44 grams and 132 grams, the ratio of C is to O combining is 12:32 and 36:96, and this ratio comes out to be 1:2.6 for both, which means that carbon dioxide obtained from burning coal or coke or charcoal has the same ratio of carbon is to oxygen atoms. Okay, so next we are moving to the third law of chemical combination, which is law of multiple proportions. So definite proportions is given for a fixed molecule. Law of This was given by Dalton. According to this law, any two elements or atoms combine, if combine, to form more than one molecule. अगर कोई दो एटम एक से ज़्यादा molecules बना सकते हैं, then the combination or the molecule will be such that if the amount of one is fixed, suppose A is fixed and B is varied, then the amount of V जो vary हुई है यानी X, Y, Z, they will be a simple whole number ratios. The ratio of X is to Y is to Z will be a simple whole number ratios. For example, if carbon is combining with oxygen to form CO and CO2. So here in this case CO, C is to O is 1 is to 1. C is to O यहाँ पर कितना है 1 is to 2. So if the amount of C is fixed and X is varied, then the value of X is 1 is to 2. It is varying in simple whole number ratios. So what kind of questions you can get on this? Suppose we are dealing with oxides of nitrogen and you have to prove that this law applies to that. So nitrogen and oxygen can combine to form various oxides such as NO, N2O, NO2, N2O3, N2O5. So two elements can combine to form 5 kinds of molecules. Okay, so here if we look at N is to O ratio. So in the first case it is 1 is to 1, second it is 2 is to 1, then it is 1 is to 2, 2 is to 3 and 2 is to 5. So we can fix this, let us fix this number to 2 and see what the ratio becomes. So if I am writing it again, this is 2 multiplied both sides. This is already 2. This becomes 2 and this becomes 4. This is already 2. So I'll write it as such. So if this is fixed, this is variable. So now you see the varying atom, the ratio of the atoms is either 1, 2, 3, 4, 5. So oxygen is varying in some simple whole number ratios. So this is the ratio, the numbers are whole numbers for different compounds containing the oxygen if we fix the amount of nitrogen to be 2. This is what it means. So different compounds that it forms will have a definite or a whole number ratio of the varying element or atom forming the molecule. The fourth law is named on the scientist's name is Gay-Lussac's law for gaseous volumes. So the fourth and fifth law, which is Avogadro's law, both of these laws are applicable for gaseous systems and the condition is at constant temperature and pressure. So TP value, temperature, pressure can be any value but they remains constant throughout during a reaction. So what does it say? Suppose I am taking the same example to explain you the law. All of these are gases. So initially we will look at the stoichiometry of the reaction. So what does it say? It says 2 mole reacts with 1 mole of oxygen to form 2 mole of water. So we are replacing this mole with volume. 2 volume we react with, this is 1 volume to form 2 volumes. Now this volume is basically representing any unit of volume. It can be liter, it can be ml, it can be centimeter cube, dm cube, whatever is given. So what does it mean? It means 2 liter of hydrogen combines with 1 liter of oxygen to form 2 liter of water vapors. This is what it means. Let us see an example to understand this law. So the question says 2 liter of ethane gas is burnt in oxygen to form CO2 and water vapors. So calculate the volume of oxygen required. The reaction, first thing we have to do is balance a chemical reaction. This is reacting with oxygen to form carbon dioxide and water. Everything is in the gaseous form. So we can apply this law for gases. So first thing is balancing. 2 H is balanced, oxygen will become 5 by 2. So basically 1 volume reacts with 5 by 2 volume of oxygen to form 2 volume and 1 volume. So we can replace this volume with the given unit. Okay. So 1 liter is combining with 5 by 2 liters to form 2 liters of CO2 and 1 liter of H2O. Now it is given 2 liters. So we are multiplying the whole equation with 2. This whole thing. So we can write 2 liter will combine with 5 by 2 into 2, which is 5 liter. To form 2 to the 4 liters and 2 liters. So from just by knowing the amount of C2H2, we can determine the amount of oxygen required, we can determine the amount of carbon dioxide produced and water vapors produced. So basically in this reaction, we are using 5 liters of oxygen and the products are 4 liter of carbon dioxide and 1 liter of H2O vapors. So this is the way you can apply this law directly. You don't have to do anything else. It's no mole conversion, nothing, because volume has been given and volume has to be calculated. If you want to calculate the number of oxygen, of course you have to apply this. Given condition should be at STP. So in that case you will divide 5 liters with 22.4 liters to determine the moles of oxygen required. So moving on to the last law, which is Avogadro's law. It was given by Avogadro. And it says that the volume of the gas, this is also for gases at constant temperature and pressure. So volume is proportional to the number of moles or number of molecules of the gas. So suppose if I have hydrogen in a container and it is occupying a volume of 200 ml and the number of molecules present, say X, then methane gas filled in the same cylinder having a capacity of 200 ml will have number of moles as X. So if the volume is fixed, then N is going to be the same. So irrespective of the gas, the amount is going to be the fixed. From this law, you can also say that at temperature and pressure of STP, means at STP condition, the number of moles and volume, they are fixed, means a 22.4 liter of the volume is occupied by 1 mole of an ideal gas. So if you know the volume, you can calculate the number of moles, or if you know the moles, you can calculate the number of volumes. So from this law, you can also determine this formula. Okay, so with this I will stop, and if you have any problem, any doubt, you can refine your understanding with the questions given after this lecture and understand these laws better way. Thank you very much.